What you're looking at isn't a generated image. AI image generation is already well solved. This is something different, a dynamic 2D shader asset built from signed distance function mathematics, living inside Unity, editable, and animatable through many available material properties. A signed distance function returns the distance from any point in space to a shape's boundary, negative inside, positive outside. Color every negative pixel and you have a shape. The shape isn't drawn, it's computed. A function runs at every pixel and returns a number. That number is the color. No pixels stored, no resolution limit. Because it's pure math, the shape is infinitely sharp. Zoom in as far as you like. And every dimension is a live parameter, editable without touching any code. Complex shapes come from combining simple ones, union, subtraction, intersection. Getting that composition right requires HLSL expertise. That's exactly what this system handles for you. The barrier has 4 layers. The math requires HLSL expertise most artists don't have. An LLM can write HLSL, but without grounding in real verified examples, it fails on anything complex. Even correct code needs to be manually wired into Unity's shader graph, and the parameters need sensible default values, or the shape simply doesn't appear. This system was built to remove all 4 barriers at once. One sentence enters. Here's what happens inside. The request is broken into its visual components. Each part is a retrievable unit, mapped to the geometry it implies. Each component searches a curated library of more than 200 verified SDF shapes, built and approved before the tool itself was finished. The closest matches are retrieved as structural examples, not invented from nothing. The language model's only job is to write the HLSL function, guided by the retrieved examples and 6 hard constraints that prevent the most common failure modes. The HLSL is handed to a deterministic C# backend that constructs the entire shader graph, wires every connection, and maps each function parameter to a live material property with sensible defaults, so the shape is always visible on first open. Finally, the rendered image, not the code, is evaluated by a vision model. If the shape doesn't match, the error feeds back into the next iteration, up to 3 passes. Correctness is verified by sight. Every generation runs the full loop: decompose, retrieve, compose, assemble, verify. The tool you're about to see is this pipeline running live. No nodes, no menus, no code, just a conversation and a shape. The tool starts with a simple question: what do you want to do? The tool asks what you want. You describe it. 1 sentence. The pipeline begins. You can watch every step. The shape is assembled and verified. The result is scored visually, not by reading code, but by looking at the rendered image. Effects are instant. No LLM, no recompile. Animation is a single sentence, a C# script generated and attached live. Every property was parsed first from the HLSL and exposed automatically. The shape responds live, no code touched. Getting here took real experimentation. Choosing which model to use for which task wasn't obvious. After testing 5 LLMs across hundreds of runs, Gemini Flash 3.5 gave the best speed and quality for HLSL generation, and GPT-4 proved the most reliable for visual feedback. And one finding stood out across all the tests. The knowledge base made a decisive difference. For complex shapes especially, grounding the model in verified examples was the difference between consistent results and repeated failure.